In continuation of the last videos on aromatic electrophilic substitution of basic part 1 organic chemistry, in this video we are going to study about the directive and reactive effects of halo substituents. Halo groups are ortho and para directive, but they deactivate the benzene ring. This is because due to the -I effect, halogen groups attract the electrons and thus render the benzene ring slightly electron deficient. Due to the presence of lone pair of electrons, they act as electron donors to the benzene ring also, and thus their lone pairs of electrons enter into conjugation with pi system of benzene. So due to this conjugation, they act as ortho and para directing. If we consider the resonating structures of rhenium ion due to the ortho para and meta attack of electrophile on chlorobenzene, so first let's consider ortho attack. If we consider ortho attack, then we see that the double bond between the carbon 2 and 3 of benzene moves out of the benzene ring and forms a covalent bond with the electrophile, and positive charge appears on the third position carbon atom, that is, the third carbon atom attains positive charge. Now by the successive shifting of the double bond within the ring, the positive charge shifts from the third position to the fifth position to the first position, and these are three resonating structures which are formed. Now this third resonating structures, the carbon, that carbon is positive which has chloro group attached to it. So we see that the lone pair of the electrons, lone pair electrons of the chloro group enter into conjugation with the benzene's pi system, and a double bond between chlorine or chloro group and the carbon 1 of the benzene ring is formed, and chloro group attains the positive charge. So we can say the positive charge in 1, 2, 3 structure is within the ring, and this moves out of the benzene ring in this fourth structure, and 4 resonating structures are formed. If we consider the para attack, then we see supposedly this double bond between 4th and 5 move out of the benzene ring and forms a covalent bond with the electrophile. The number 5th carbon attains the positive charge, and by the successive movement of the double bond, this positive charge shifts from the 5th position to the first position. And since this is that carbon atom which is attached or which is bonded to the chloro group, the lone pair of the chloro group enters into migration with the benzene's pi system, and a double bond is formed with chloro group and the first carbon atom, and the positive charge is moved out of the benzene ring, and this chloro group becomes positive. Then in the next we see that this double bond, the electron pair of the double bond between chloro group and the C1 carbon atom moves back on the chloro group, and the double bond between carbon 2 and carbon 3 moves between C1 and C2. So positive charges developed on the third carbon atom, and a double bond is between first and second. So we see that in all, when the positive charge is within the ring, it is on the third position, fifth position and the first position, and in the fourth resonating structures, the positive charge has moved out of the benzene ring and it is on the chloro group. So in all there are 4 resonating structures. Now if we consider the meta attack, then we see that the bond pair between second and third carbon atom moves out and forms a covalent bond with the electrophile, and the carbon at the second position attains positive charge. By the shifting of the double bond within the ring, this positive charge shifts from the second position to the sixth position to the fourth position. And in these resonating structures, we see that there is not a single structure in which the carbon which is directly bonded to the chloro group is positively charged. Hence, the lone pair of the chloro group cannot enter into conjugation with the benzene's pi system. Hence, only 3 resonating structures are formed with the meta attack. And we know that as the number of resonating structures is more, the stability is more. So with the ortho and para attack, 4 resonating structures are formed in each case, and with meta attack only 3 resonating structures are formed. And also we see that when ortho para attack takes place, then in meta attack also we see that the halogen atom makes the ring positive because of the minus effect. It's greater than the plus R effect. Therefore, the activation energy for the electrophilic substitution of chlorobenzene is more than that of benzene. Thus, halo groups deactivate. Now we come to ortho or para ratio. In a monosubstituted benzene, for example C6H5Y, and this Y group is ortho and para directing, then it is 2 ortho positions and 1 para positions for electrophilic substitution. Thus, the ortho and para product should be in the ratio of 2:1, but it is not so. Ortho and para ratio for electrophilic substitution reaction is different in different reaction. Factors affecting ortho-para ratio. Size of the attacking electrophile and the substituent group. Electronic effect of the substituent present on the benzene ring. Effect of the temperature and the effect of the solvent. Under similar conditions, when nitration of the alkyl benzene takes place, ortho-para ratio decreases in the following order. For methyl, it is the highest, which is greater than ethyl. It is greater than for secondary alkyl, and it is greater than the tertiary alkyl. This is all for today. Thank you.